Hello, everybody. I am Matt Karinga, and I'm going to lead our session today. I'm a professor at Adelphi University, and I'm going to talk a little bit about our open source software project, New York City Schools, which is a Python library to make it easier to analyze school data, and then share a little bit of the research that we've begun for a project that's joint between Adelphi and Columbia. And hopefully we're going to have some time to actually write some code. So we've saved some time at the end where we can dive in and you can write some of your first codes, make some maps, and get into that a little bit. And this session is called Mapping School and Census Data. And we're going to just look at a couple maps that we've drawn that are combining some census data with the data available about New York City schools. Here's the plan. I'm going to talk about our project a little bit and talk about what kind of spatial data there is. We're going to look at some examples of work, both the code and the output. And then we have some time for some programming workshops. And I'm co-presenting with our graduate research assistant, Jacob Geyer. Jacob is here too, and he's going to walk through some of the census stuff that he's been working on. And then you can join Jacob if you're just getting started. He'll help you make your very first map. If you have other questions or want to do something specific with census data, you can join me in breakout room 2, and we'll look at some of that. Or we can also just dive more deeply into the code at that point if people are interested. What we're presenting today is in large part thanks to the Spencer Foundation, which has funded a 3-year research grant called Mapping School Buildings using sensory ethnographic methods, a district-wide study of school architecture and spatial justice. This is thanks to our PI, Elizabeth DeFreitas, who is here, a joint project with Adelphi and Columbia University. So Liz and I we're from the MIXI Institute for STEM and the Imagination. This is a relatively new research and practice institute that we began in 2020. And our goal is to find new creative ways to study technology and society, both by creating new technology, but also new approaches and methods. And we're really interested in this project and looking at the kind of spatial and material aspects of learning, where students learn, when they learn, how that changes over time, how it changes with seasons. And part of what we're going to do is study schools with kids to help them develop their own methods for studying the space of their learning, to help them learn to write code, to learn CAD programs, to become ethnographers of their own education and learning. So we're working closely with some schools in Brooklyn in District 13, and also with UA Maker Academy, which is across the bridge from us in downtown Manhattan. And this spring, we're working on some of the basic background research, and in the fall, we're going to start working with the students directly. We're very happy to be joined with the Center for Spatial Research with their director, Laura Kurgan. They do a lot of fantastic work around spatial visual narratives. They have a fantastic project about the prison system and looking at ways to dig into the spatial aspects of the financing of it. A more recent project where they're creating historical maps of New York, going through all the neighborhoods and looking at who lived in which buildings over time, and putting that together into interactive maps. So that's kind of our core project team. And what I'm talking about today mostly is this Python library. So I started this code a couple years ago to teach computer science courses where I wanted to be able to use real data that was meaningful as a teaching tool. So I was cleaning some of the school data and creating data sets, and decided to clean it up a little bit more and make it an open source library. So it's available if you're a Python developer on PyPy through pip. You can download and install it. And the idea generally, and in particular for this project, is that we want to make computing, computer science, data viz more widely available. And as a goal of actually changing the types of policies that are made and who's able to be involved in those decisions. So I'll just put that as the background for what we're doing a little bit. All right. So what does the library do? Basically clean and consistent data, Python API, if you're already working in Python, and then a series of examples and resources of how to do both spatial analysis, but also statistical analysis, some basic machine learning and things like that. A big part of this project and a constant source of frustration is getting clean data. So there's a lot of data about schools, and we pull most of the data through the New York City Schools Open Data Portal, but we also combine it with other data out there from New York State, from, and I guess directly from the DOE, data that they haven't released on the Open Data Portal. And what we try to do is make it consistent and ready to use for analysis. So it might be that on the, well, definitely is true that on the data portal, if you want to see the school demographics, like who goes to what schools, they have many different data sets with different years and different column names. But using our data, for example, you can get from 2006 to 2022, a core set of demographic data in a single call. So that's the kind of thing that we're trying to do with our software. All right. So I want to switch over to some code and talk about what type of spatial data we have in the Open Data Portal around schools. So we'll just go to the most basic spatial data we have. We know where the school districts are in New York. So New York City schools are organized into 32 geographic districts, right? And they're all different colors here. And then we know where the schools are. So they're point data for each school building. And we can pull this from the data portal and then plot it in the map. And if you see, it's just not too much code, maybe about 15 lines of code to make this map, right? So we are building on some well-known libraries, Pandas, GeoPandas, Folium. So these are kind of the standard libraries for doing this type of analysis. And you'll see that we're going to use them for some of the maps we're making today. So just some quick maps. Like one of the key things that we want to do is make maps that try to help us to understand school data. So I pulled a map here, and it's 2022, the concentration of English as a new language students, right? So these are the 32 districts. Let me see that in a little bit, right? And this is called a choropleth, this map. So it's shaded in blue, where darker blue means that they have a higher percentage in the district of new English speakers, right? So we see District 32, which is in Bushwick, District 6, which is Washington Heights and Inwood, District 24 have the highest concentration of new English speakers in their schools, right? So this is Queens, this is Jackson Heights and other parts of Queens here, right? And then you can see District 3, the Upper West Side, all through Central Brooklyn, District 1. There are not as many, so they have the least, the smallest English-speaking population in the schools on average, right? So this kind of thing that we can do with a little bit of code. And this is the type of map you'd probably be able to make, even if you haven't written any code before the end of the session. So in this same notebook file, what we can do is put this in a loop and see how the data changes over time. So this is from 2005 until 2022. And we can kind of see the shift in where English-speaking ESL, ELL students are located, right? So up here, we have District 6 consistent the whole way through, but then we can see them becoming concentrated in other areas out here in like Fort Hamilton, Sunset Park, definitely a big growth in Central Queens, right? So the school data gives us a sense of changing demographics in the city, right? In school demographics. And later on, we're going to add some census data in there. So just looking at a different index here, this is the percent of students who are living in poverty, where darker red means a higher percentage, and how it changed over time. So each plot here has its own scale, and you can see that after the real estate crash in 2008, we actually had some darker red for a couple of years, where in general, the whole city on average had more students in poverty. And it's kind of stayed higher than it was back in 2005, right? And then just pulled another map where I put the district labels in here. This is just two plots here, 2005 and 2022. And this is where the white students have moved as a comparison between the first year in our data set and the last year in our data set. And on top of it, I labeled it with the percentage in each area. And just to show the difference, some of the considerations. So these maps are actually, the colors are not consistent across the two plots. So I just plotted another one where they're plotted on the same scale. So here you can see relative to the other neighborhoods where the whites are more concentrated, but it might be hard to read in the presentation. But back in 2005, Staten Island was 55% white, whereas in the most recent data, it's only 35% white, but they're both shaded the same because that's the darkest color in that data set. If we want to compare them to each other, we can see a different way to visualize the shifts in the data here, right? So all of these maps are static maps. They're not interactive. You can't click on things and get more information. And they're built on top of a library called Matplotlib. And at its core, you get the data you want, and then you call this function plot, and it creates a map for you. So there's not much more to it than that to create a basic plot like this. If you have geographic data, you can call plot, and it's easy to highlight different data in it. So what I'm going to do now is stop the share, and Jacob, my colleague, is actually going to show us some interactive maps and some of the interactive analysis that we can do by actually letting people investigate the maps and look at different data points within it.
This is one of the demos that we'll be working with today. So if I just go down to the bottom, this is looking at New York City school data. And we use this explore function when we want to kind of be able to drag around in maps. This one in particular is a simple plot of just all the schools in New York City. And we've set up a info pop-up block. So you can zoom in, get myself squared away. And if you hover over, you can actually see school names and click them, and then you'll have, data right there for demographic data, different percentages of different students, total enrollment, the poverty percentage in each school. So this is like a very basic map. It only takes a few lines of code to make. And below this map, we have, something a little more complicated where we add in our district layers and we give the schools somewhat of a legend. So you see all these pink dots on this map, and I believe you can see it if I move this around, that we show the different types of schools. There's charter schools. Community schools are basically just standard schools in New York City DOE. So you can kind of get a general idea of how many schools are in each. There are alternative schools, and there are District 75 schools, which are specialized for students with disabilities. And this map works pretty similarly to the last one, where you can go and click on a school and find your data, but you also have the added layer of what district you're in, and it's easily navigable. So this, instead of using the plot function that Matt was using prior, this actually uses the explore function right here. So, it's a different way to observe your data. You basically just need to have your data set up with geometry, and then you can plot them in layers. You know, you plot one layer of district data, and then on top of that, you can add your school data. And this can work for, you know, as many layers as you really want, and using any type of data you might want. Maybe you don't want to look at the different types of schools. Maybe you want to look at the test scores of certain schools. So it's a really useful tool when you're looking to interact with your map, zoom in, zoom out, and show different regions. Did you want me to go over census map as well?
Yeah, you can show the census stuff now too.
So this was a separate map. So this is for the census data.
So the census data is outside of our project, but we've been working with it, and we just want to show some ways that you can key in census data with existing data that's part of either our project or more generally the open data portal school data.
Yeah, exactly. So census data works similarly, where we retrieve it through the census API, and basically everything comes in a table, right? But this map we created actually shows a choropleth of household income over the city. So you can kind of see the darker blue shades are higher income. Sorry, if I remember right. You can see Manhattan is pretty dark purple. And as you move into deeper parts of Brooklyn, Queens, you have lighter values. And these are actually tracks, which if I zoom in enough, you can actually see I'm highlighting these small areas of different blocks of almost neighborhoods coming together, where you can see the different household income in this neighborhood. I believe this is 2020. So you can click on it. You can see what the population is like there. You could have really any data you want in these pop-ups, but really helpful for these tracks where you can zoom in and you can see the exact blocks you're getting your data from the population. And obviously, as you zoom out, you get a cool detailed image giving you a lot of information at once of the disparity in household income that what we see. So this is again using the explore function on Python to look at this data.
I changed their colors, Jacob. I don't know if you knew that.
Yeah, I saw. Yeah, it looks better this way. Yeah, that's another thing you can do with the Explorer. Really, any mapping is you can change your map colors to really anything that you want. You know, this one's good for a trend to show from high to low. In other cases, you might just want completely different colors representing your data. But yeah, that's basically the explore function. We can talk about this more when we go through. These are one of the two demos I wanted to go through in the workshop, so we can talk about the how the code works and walking through it with you guys.
All right. So why don't I show some of the census maps that I've been working on. I'll show some of the different layered stuff that we're doing too. Let me show them in here because there are some slight differences between Colab, and this is the software that I'm using at home. This software is called Visual Studio Code, right? And this is also a Jupyter notebook that's running within the development environment. Let me zoom in a little. So in this file, I'm combining the census data from data that I already compiled. So in another program, I wrote it and I saved it, and now I'm just loading it again. And then I'm loading some data that we already have, the demographic data, school locations, the district size. And here I'm getting the building footprints for all of the schools in New York City. So that's the actual shape on the city at the block level of the school buildings, right? And this map shows us plotting school poverty level as the circles on top of census tracts that are shaded on using the same color map. So let's zoom in to where we're working up here in District 13, right? So District 13 in New York is basically Prospect Heights, Clinton Hill, parts of Bed-Stuy, up along the Navy Yard, downtown Brooklyn, and a little bit of Park Slope. So it's generally in this area. And what's interesting to me looking at this map is if you see wealthy schools, which are darker blue, in maybe a less wealthy neighborhood, right? So if I mouse over the neighborhood, it tells me the census tract and the median income of $119,000. I mouse over the school and I can see the name of the school, and it's only 13% of the students are below the poverty level, right? So we see the same thing. Like, where do we have, like, we see a lot of poor schools in poor neighborhoods, right? And then we get some wealthier schools in wealthier neighborhoods. And if we zoom out, we kind of get a sense of the city and where the schools are and where the wealthy people and the poor people are living, right? So this is just an example of combining census data with school data. So we can look at them both at the same time. Now, the next map that I'm going to show, this is called a dot density map. And here, each dot is representing only 10 people. So, and they're randomly placed within their census tract, right? So this is the black border shows District 13. And then I've joined it with all of the neighboring and overlapping census tracts because they don't exactly coincide, right? The school districts and census tracts aren't on the same lines. So right now we're just seeing who lives where in the neighborhood, right? So blue is, and this is based on the census data, as Black, African American, purple, white, yellow are Asian, Hispanic, are green, right? So if you zoom out, you can get a better sense of where they are generally, right? You zoom in and you can actually see what different tracts look like and where people are living, right? So once I have this base map, what I did was took it again, and using that same base map, I actually plot the school footprints on it. So each of these blocks represents a school building within District 13. And they are interactive so that when you mouse over them, you can see what school it is based on the DBN, which is the school ID. You click onto it and you can get some information about that school, right? And then I shaded the schools according to the percentage of Black students, because I thought it might be interesting as a first analysis to see if the schools reflected the neighborhood, or to what degree the schools reflected the neighborhood that they're placed in, right? So. All right. And again, the code is here for you to see this. And this, like this dot density map is a combination of both functions that we wrote in our library, as well as custom code that we wrote to supply the data for it and make it into a map. And then the last one, we'll look at this map, and I'll skip to the end. All right, these are school buildings plotted by the year that they were open based on the Department of Buildings data. All right, but just to go up to the top for a little bit of background, I started looking at this because I was looking at this idea of co-locations where we have multiple schools in one building. And I just created a chart of schools opened by year, and we see basically immigration spikes and then these crazy spikes in new school openings in 1999, right? So this is when charter schools were created, and this is also the kind of onset of the small schools movement, where a lot of the large high schools especially were broken up into 5 or 6 different schools, and we see this kind of explosion of schools. And then using the same data, we can plot it where we separate charter school openings just since 99 versus non-charter openings. And we can see at first it was mostly non-charters, and these are the small schools that were being created from large schools. And then we have an uptick in charter schools. All right. So this first map is school openings by the year the school was opened, right? And we have our earliest school here, the Oliver H. Perry School, and I haven't actually looked into it. So if anyone is familiar with the school, I'm curious to hear about its background and history. And then we have the newest schools are in this blue here, right? So I'm showing you the color palette. With this many things, I was trying to get a good palette where it would help us distinguish the schools. But then I made the legend interactive so that it would highlight just one year if you wanted to, and kind of fade out the other schools so you could have a better sense of it, but still see where they were in relation to other schools in the map. So taking the same data, this is the school openings, but I made the same map with building openings, right? And clearly there are a couple things off with this data because some of the buildings are in the future, and I'm not sure what's going on with that. I need to investigate that a little bit. But you can see we have a couple schools in buildings that were from the 1870s. And a lot of the buildings were built either at the beginning of the 20th century, right? Or mid-century. So we have this explosion of building here in the post-war era, right? So if we want to see where all these, in which neighborhoods these 1960s buildings were, we can click on it and get a sense. And the 50s buildings were very near them, right? So we only have, well, I'm not sure about these 50 schools that were built, but there's been a lot less new construction and a lot more co-location of schools in the last 20 years. All right. I'm going to stop my share. And briefly, before we dive into the workshop period, if there are any questions, and I see a couple like here already. So there are 2 ways to plot points. Becca, one is to actually just have them a fixed size in pixels. So that's better when you're zoomed out if you have a 4-pixel circle. The other way is to actually plot them based on their geographic size on the map. So you could plot it at 50 meters or 20 meters. That way, when you zoom in, they get larger and they take up more of the map. The easier way is to just plot them all the same size. It takes a couple extra lines of code to actually plot them in a relative size based on how it is. So let me share my screen, and I will put this link again in the Slack, but I put in this agenda for today, I linked to all of the code we shared, and each of these opens up a notebook that you'd be able to, if you have a Google account, you can make your own copy of it and start working with it. And that's what we're going to do now. So I haven't updated the official docs yet with these examples. So I'll put them in there under the case studies also, so they're there. They are in the GitHub though already. The notebooks are there under the drafts folder if anyone's looking for them. So you can get them there, but the collab, they're ready to go and to work on.
There's also a question, Matt, from Dan Eldridge about facility data. I was just going to say that the project will include that. So this is year one of our project, and we're working with individual schools and working at that level of trying to get data around facilities. And we're interested in anybody who wants to connect with us and join with this project. So please reach out after the workshop if you're interested.
Yeah, we know that a lot of people are presenting on similar topics and doing similar work. So we've been excited looking through the program schedule. There are two ways in the official data that they measure poverty. One is they're basically based on the surveys they give. One is called the ENI, the Economic Need Index, and the other one is the poverty percentage, which used to be free lunch and free reduced lunch. So those measures actually changed a couple times in the data set. So they're not necessarily exactly the same measure from each year. Noel, I see you.
Yeah, as you're digging through this, something that we've heard is it's kind of difficult to work with DOE data because of the very disparate data sets. And so as you find new colleagues, please synthesize direct feedback that we can pass along to the Open Data program. Like we're finding little things that we want to see included in the Open Data set, and just having a broader understanding that the Open Data program is taking advice and taking that back to the Department of Education is really important, because there's so many opportunities to improve the Department of Education's data and the way that it's organized on the Open Data portal. So please don't be silent on those opportunities to improve the data set. We really need some real community momentum to get the DOE to think how it's publishing the data and improve the data generally.
Yeah. Dan, I see you have a bunch of questions. A lot of this data is available in very roundabout ways. And I've been looking at it, so I can help you if you want to dig into it. And there's actually a lot of data around heating and ventilation that came out during COVID, where they did a bunch of surveys in the schools. So some of that is in there. It's not in the data portal yet, but it's available to scrape through the DOE site. All right. We're going to create 2 breakout rooms, and you're welcome to join us and actually make some code. We'll show you how Colab works. And so room 1, you're going to be with Jacob. Room 2, you're going to be with me. And we hope that you do take a look. All right. You can just choose the room that you want to go into. All right. So we really just want to thank you for coming and for listening. Please feel free to reach out to us if you're working on school data stuff. We definitely want to be a resource and help you out. If you are having trouble getting the Python library up and running, let us know. There's a Discord for it where you can reach out to us, but you can also just shoot me an email directly. And that's it.